Hi, my name is Alex Pluto and this is Package Main. Recently I found a very interesting Golang package Triangle to create triangulated images from any source. And in this video I want to make a code review for it. We will make it cleaner, faster and probably fix some bugs. Make sense? Let's start. First of all, let's go get this package and open in our text editor. Go get github.com/yasimov/triangle and then go to this folder. Let's create our branch first, so later we can create a pull request. We call it refactor. Okay, let's see what this package has inside. We have a bunch of files in triangle package using Delaunay technique to create images, and we have some filters, blur, etc. We have a CMD folder with executable main.go file. In this review, we will not focus on all files, but we will focus on main.go file, and we will review and refactor it. So let's try to test it. Let's see how this executable work. We will use gorun. Let's see what options do we have here. We have an input file, we have output file, and we have a bunch of options which are optional. So let's try simple case with one input file. cmd triangle main.go. I have a nice image of Gopher. It should be here. And we will save it in current folder. Alright, it works. We have a Gopher JPEG. It's nice that it prints time spent to this operation, number of triangles generated, and number of points. And let's open this Gopher JPEG file. Cool, it works. Let's review main.go file. We have a list of packages imported here, including our triangle package. We have constants, we have flags, we have mutex. We are using runtime gomaxprox. I will review it later. I have concerns about it. Then we have a main function. First of all, we open the source file. And actually it can be a directory. So we have a switch here. If it's directory, we check for available extensions, get list of files in directory, iterate over the files, filter by extensions, and then we iterate over valid images and start a coroutine where we call a process function to process the image. And then we have a channel with results and we print saved as or error. Another case, if input parameter is a file, so we just open it and call process function without a loop. And we have a big function process with a, so here we use a mutex. We lock and unlock it. And we have some image processing here. Probably we are not going to focus too much on this function, but let's see. And we have a local function to unRGBA. And we have a spinner function. I think it's to print this spinner when we print generated triangulated image. Okay, let's do something. What I want to do first is I want to run a Go format tool to see if our files are formatted well. We can do it recursively. As you can see, there are a lot of files changed now. And I think it's a good practice to run Go format on file save. Let's go next. So I had a concern about GOMAX procs. As I know, in new Golang versions, the GOMAX procs is already set as number of CPU available on your platform. So this code doesn't make sense. Let's verify. Is it true? So we will print the number of processors and the value of GOMAX procs. And then, but we change it to 0, so it will return the current value. And let's run it again. So it's 8.8. It doesn't make sense to set it. So we can safely remove the entire init function. So as I saw, it can be used as directory, and it will save new images into some directory. Let's verify this case. So I will just remove the file name from input, and it will save to Gopher folder in current directory. Let's try it out. Alright, and we have error here. Open file, no such file or directory. And as you can see, my input is package main02. But what error says, it uses the image from the wrong folder. Let's check why it happened. First of all, for me it's not clear where this error came from, because everywhere we use log.fatal and we don't send any context. So what I will do now is I will check all log.fatal and probably add some context, so I will know where error happened. Here, unable to open source, fatal F. Here say unable to read dir. Unable to get dir stats. It's okay. Let's set it here. Unable to get absolute path. Oh, a lot of places. Unable to get. I want to make it different. Absolute path of source dir. Alright. And he is unable to open source file. It should be F here and here. It's actually the same, and I see that code in this case and also in a loop here, it's very similar. You just open a file, call process, and then we handle errors. So later we are going to combine it. Let's run it again. Alright, unable to open source file. So it came from here. Let's see what is source file. It's in var. In is dir/. image. What is dir? Alright, so when we call this file path .apps, it actually returns a little bit strange folder, the current one with /gopher reach. And I think we can do it much simpler, because we already sent input directory as parameter, so we can just use it. So dir, let's just replace it. Dir will be source, but I just want to remove the right slash because we added there. I don't want to have double slashes. Trim right source slash. Alright, so when we have a dir slash image, let's try it out. It works. We fixed the first bug. Now let's see gopher reach and just a gopher. Let's test one more scenario when input is a file and output is a dir. We should get some error here. So we are using the same, but input will be gopher JPEG. As you can see, we have a Golang panic here. Invalid memory address on line 154. On line 154, we are using f as result of process function, and I think it's nil because process error is not nil. So let's rename it to file.name so we can use a source. We are sure that it's not nil. And now we don't use f from process, so let's just omit it. And let's try again. Alright, we have a just error here. Open gopher is directory. But what I can see is that it's not printing, error is not printing on the new line. I will check it. Let's see what do we have in the process. How many lines generated? Alright, because if everything is fine, we print /n at the end. But if it's not fine, we are not printing it. So I think that we should add it before error. And same is here. As I told, later we will combine all these calls of process function. Let's see. Alright, error is printing on a new line. What's next? Let's review the channels. Why do we use channel? We use them for sending output, and then we just iterate over the channel and print the results. That's good, but except one thing. In process function, we are using mutex. So anyway, the process functions will be executed one by one. So there is no actual concurrency here. So I think it's more simple to just remove this channel and everything will be the same. And we will move result processing inside the coroutine. Let's try it. We remove this channel and we move this check here. Then remove also this comment. If error is not nil, we print error. By the way, we fixed one more error because here we checked f.error, but we printed error.error. And error converting image. And I think we should, as f.image was output, we should use file here as well, because f will be null. Else saved as output.name. Now we don't need this closer, and we don't need this for loop. Let's verify if it works. We should test it with folders because it's there. Right, nothing is happening. I see, because I removed waitGroup.wait function. We should have it outside of this loop. Image 1, image 2, same results. Again, we are using waitGroup and we are calling goroutine, but inside the goroutine we call this process function and it's using lock. So I think that we can just remove the lock and remove goroutine and remove waitGroup. Let's do it and verify if it still works. We remove this mutex, remove waitGroup, and let's now change. We don't need done anymore. We don't need goroutines anymore. Now we were using in, so let's just set in here as, we put it here and remove this goroutine call. Alright, my IDE doesn't show any errors except this one because we don't use waitGroup anymore. Good, let's test it again. Image 1, image 2. But now I see one very strange thing because we are generating triangulated image twice, here and here. And as I remember, we are using spinner function to print it, so let's see how it works. Spinner, so right, when we call a spinner function, we call it goroutine. But actually what happens that we never stop this goroutine. So there is a possibility that it's still running after we finish our process function. So how I'm going to change it? I will create a type spinner with two functions, start and stop. And I will stop the spinner using the stop channel. So our type will have one field stop chain, which will be the chain of struct. And then we change spinner function, actually it will be the start function of spinner type. And let's create function stop without any parameters. What we will do in stop, we will send to s.stopchain. We will send some empty struct. What we need to do now, we need to handle this stop process. So here we can do, by the way, first of all, let's initialize our channel. Stop channel is make channel struct size 1. Now let's handle this stop signal in our start function. I will use a select, this case. So if something is here, we are just going to return. And in default case, we will still continue printing. Let's change the usage of spinner function to our new struct. So now we need to initialize a spinner as like this, and then we call spinner start. Sorry, not stop. Spinner start, and we need to stop before we actually print in something else. Spinner stop. Let's try it out. Alright, good. We don't have any duplication. As I said you before, now I want to combine the call of process function. Because we have some code duplication, especially error checking here when it's single file and here when we iterate over the files in directory. So I think this part of code will be common. And what I'm going to do, I'm going to define the list of files we need to process later. And it will be the hash map input output. So I call it to process. So we don't need var, it will be a map. It will be map string. And let's fill this map in this loop. So it will be to process in is output. And let's remove this code. I think I also need to remove this open, and we can do it when we will process, because here is the same code. Alright, let's remove it. And here to process, actually we'll have only one element. It will be source, and the output is destination. Alright, now let's iterate over the process map. So it will be in, out, range to process, and we are going to do this code. V is file close. I think I can move file close here. And it's not source, it's in. And it's not destination, it's out. And the same we should put here. Good. This case is very clear now, and this one is also small. It's not, should be star, and it should be out here. Alright, let's test it out. Now we are testing this directory, one file, second file. Good. Let's try it now with one single file. And it's also good. What I also don't like about main.go file is that we have this huge process function here. And I think that it should be a part of triangle package. It makes main.go file smaller, and actually it's not responsibility of command line file. And it will give user ability to use this function as a package function. So let's do it. Let's create a process.go file here in triangle. It will be a package triangle. And then let's for now just move this function and also one helper function to an RGBA to our new file. Let's make this function exported, of course. We will need to replace this 3 dot because now it's same package, so we don't need it. Let's replace just to nothing. Alright, as I see, we are using Spinner now, but Spinner is a part of main.go. So I think that exported functions of package shouldn't print anything to output. So I'm moving all print functions to main.go. I will start with Spinner. It's very good that we call process only in one place, so it's more easy to change. And then we use as.stop. And actually, it's not the process now, it's triangle.process. And as I remember, we also printing something here. We need now to remove stop, and let's move all these prints to main.go. We will print it when everything is fine, when error is nil. And I also think that we should move calculation of time out of process function. So let's do start is time now. And we print time since start seconds. Alright, we are missing some variables, triangles and points. So let's return them from process function, so we can print them later. Let's return triangles and points. And we need to change the function description. Where actually triangles, it's here. Alright. We had the local variables here, triangles and points, and I think we shouldn't have them on package level. We should define them inside, so triangles and then point, and we don't need this prefix anymore. And let's define like this. Triangles. I think we shouldn't use package level vars here, so I'm going to do it everywhere. We don't use start anymore. Let's remove this. Alright, I will see later what errors we have, but let's just remove it also from here. I think we can remove all, leaving only flags in command line main.go file. And we are returning triangles here and points. And then later when we print, yeah, we use them. All good. What error do we have here? Alright, because we are using local variable blur radius. No, it's a flag value. So now we need to pass flags to our function. And what actually flags are their options. So I think that we can create a type processor with options and then call the processor.process, and we will have all options as type properties. So let's create a type processor struct, and then what will be inside, we need to pass to move all flags here. All flags except input and output, because they are parameters to our function. So let's do like this, and then we can use a multi-cursor to remove it. And to remember, it was ints, int, what's noise is int, then float 64 and booleans. int float 64 boolean, and they should be exported. So let's do like this. Good. And it will be a function of our type. So let's do like this. Processor, process. And now we need to change. Blur radius is processor dot blur radius. This one is file, find, Sobel, points threshold, max points, if grayscale, if is solid. Let's save it, and alright, we have wireframe. Will be wireframe. We don't have constants here, so I think that we also can move constants to our process.go file. Let's define in the beginning. Golint shows me this error, so I will type like this. And we don't have source image defined. So source image, yeah, it was a local, no, it was a package variable. Now it will be a function variable. Source image, what is gray? It's image NRGBA, and here image NRGBA. So alright, image NRGBA. Alright, and we should define line color. Color RGBA. And we still need to replace here. And replace noise. And we don't use time anymore here. And we pass noise here. Right, our package function has no errors anymore. Let's pass flags to options of our processor. So we can define the processor here. Will be new, or let's do these options. Triangle processor. And now we need to pass all flags to options. It will be so how we are going to do it. We'll just do like this, then replace Sobel points, max points, wireframe, and now we need to change how do we call process function, because we don't call as a package function, we call as processor.process. Alright, I think now it's time to test it. Let's test the same example when we have one single file. Generating. Yes, so everything is fine. What we did, we removed the format functions printf from package function process. We moved to a new file. So as you see, command line main.go file now is 2 times less. It has only functions related to command line application, like spinner, then processing of input and flags, etc. Let's see what we can do in process.go. Yeah, I like to describe all exported types because my Golint shows errors. So processor type with processing options. And then, yeah, we also need to define constants, but it can be done later. Why do we need to use loop like this, iterating using the index? Where do we use index? Triangles from I. So only in one place. It can be done with just for range loop. It's triangle, range, triangles, and remove these two lines. And we forgot this one. Let's see. Also, I think it will be good to verify it with directory, that everything works well, like this. So, first one and second. Everything is good. Now I'm going to remove some unused packages. Verify that it still works. And that's it. I will make a pull request for this review and send it to the owner on the GitHub. So check this link out. I hope it was interesting and you enjoyed it. Thanks a lot and see you later.